Hi, everybody. Today is August 24th, and this is the SIG architecture, bi-weekly meetings. Please, good to see you all. I didn't expect this many people here, so which is a good sign. So we've been skipping this meeting for a while because of the release pressures and whatnot. So good to see you all back here, and let's get started. Anyone new here who would like to introduce themselves? Going once, going twice.
I am new. After a long time, I joined. So this is Leila. I usually go to SIG API machinery, and I'm today here to discuss the first item in the agenda. Is interesting to me. Thank you.
Sounds good, Leila. Yeah, I've seen you in all PRs and stuff. Good to see you face to face. Sergey, hi. Joe.
Hello.
Logical Ham and Wojtek. Good to see you all.
Good to see you, Dems.
Okay. Let me open up what's on the agenda today. Rian is the first item. Would you like to get started on that?
Sure, that's me, right?
I feel
No?
extraordinarily honored and a little awkward that I have such a big audience for only one item. We kicked off this release very early with the 13-point test. It has been reviewed. I've been to SIG storage this morning to go ask for a approve. We already got an LGTM for it. Hopefully they will merge it. If there's anybody here that also want to give a high five and a thumbs up there, it would be appreciated. We're just waiting on SIG storage to review and get it merged. While I have the floor, let me then talk about the rest of conformance and where we are. We still have a beautiful up to the right going. Last release, if I just click over, we had 21 endpoints coming in. A little bit of that is a carryover because of the way that this was written, that endpoints was pulled forward. Still looking good. And then we have 48 endpoints remaining for conformance, of which basically just about 90% of those are storage endpoints, which right in the beginning of conformance program, there was consideration the storage shouldn't be eligible. And then after some discussion last year, Jordan pointed out that we should have it there. So we brought that back in. So diligently working at that. And then the next test would be 7 endpoints for storage class that we're busy looking at and researching. So the target of where we burn through about 20 endpoints per release. So we hope to be done with all endpoints by first release next year or no later than the second release next year. We should be done with everything, and after that would be gatekeeping and checking that no new debt comes in.
Rian, can you walk us through a little bit of the, what is the fallout and how we need to deal with it? Because, for starters, all the different environments that people tend to use for Kubernetes, like Minikube or Kind and things like that, do they all have some option for persistent volumes baked in?
That is a technical question, which I don't think I would be. Stephen, do you want to chime in on that, or anybody else?
Since I was the one who actually said that storage should be in performance, this is less about having storage provisioning and more about having the API surface there reliably. So this is making sure that people can register a storage class and can create a PVC and a PV, so that if they were bringing like a CSI driver, it could make use of that API surface.
Okay, so we don't mandate a CSI driver to be present, but we only test for the the API and the life cycle of the things within the resources within the API.
Right. The conformance testing is making sure that these APIs are there, can be used, so that anything can rely on. Yeah.
Okay. I like it way better than mandating a CSI driver for sure. Any other questions, concerns from anybody else?
And then also the way that we test it is actually just exercising the API. We do not create any storage or anything like that. So it's just, as Jordan said, testing the presence and activity.
Sounds good to me.
Then, which is not fully applicable to conformance here, but might be interesting to this group, there is requests from the CNCF moving forward that they also want to put conformance tests in for Knative and Istio, as there are basic iterations on top of the API of Kubernetes. So we are busy. We already have a Istio Snoop test version running that can show what's the coverage on Istio, and we're busy working on Knative, which is a little more complicated. So there is discussion whether we're going to have tick boxes on API Snoop as it is today, that you just activate API Snoop for Istio and Knative, or have separate pages that replicate the work there. So I'm not exactly sure how it's going to run, but it's exciting that it's actually expanding to other parts of the ecosystem as well.
Sounds good. Thank you. Okay. If there are no more questions for Rian, Geological Han, would you like to start, introduce the topic for dynamic feature flag?
Sure. Yeah. So I've been working with Joe and Jordan, Ben, Layla, Wojciech on reliable upgrades, and we've been thinking about the problem a lot. And there was an earlier proposal by Daniel Smith to make feature flags dynamic, and there were some really great ideas in there, specifically about being able to upgrade Kubernetes to a version X+1, but staying compatible with the version underneath it. And like the reason why you would want to do this is because it gives you more granular steps. So basically, if you fail during an upgrade sequence, you have a little bit more information about like what's failing because of when you failed. So what we are basically proposing is extending feature flags so that we can have a stage promotion version embedded in the struct that we use to represent feature gates. And basically what this allows us to do is it allows us to sort of preserve this core idea that Daniel Smith had about feature flags, dynamic feature flags, without like necessarily the complexity of making all feature flags dynamic, which can be a little bit thorny when you are thinking about kubelets and like static pods and all this stuff. There's a doc. I have shared it in the chat. Feedback would be much appreciated. Yeah, I just wanted to see what SIG Arc thought about amending feature gates so that we can basically have this kind of functionality. And yeah, if people would be receptive to this.
So who would be able to change the feature flag in like what kind of, and does it persist across restarts of the API server?
No, we would be hard coding. So like basically it's dynamic feature flags without the dynamic aspect of it. We just encode when the feature gate was promoted to that stage. And if we have that bit in the feature gate, then basically we can compute which feature gates would have been enabled at a specific version. That allows us to bring up like an N+1 server using only features that were enabled at N.
Okay,
And
I see. Yeah,
and
so right now we have comments in the code when
Yes.
things went from alpha to beta and
Yes.
GA, and like that one should be in a data structure that is
Yes.
lookupable.
Exactly.
Okay.
Yeah, dynamic might be the wrong word. It might be maybe version aware feature gates would be a better name for this at this point.
Yeah, there's
yeah,
all sorts
taking-
of connotations, right? Especially because of the dynamic stuff that we had in kubelet and we had to rip out.
Yeah, this is really an incremental step from where we're at now. It wouldn't preclude us from, figuring out dynamic stuff in the future, but there's a lot of stuff wrapped up in that, like Han said. And so if we can make feature gates smarter than they are today but still pretty easy to like understand the flow of without complicating that flow, there are some pretty neat properties that come out of that.
So, for example, you throw in a QAPI server 129 and have a switch in there says mimic 128. So essentially, it looks and feels like a 128. Is that?
That exactly. So formalizing what we do today, where we roll a lot of things out over 2 releases, but we just kind of remember or add comments or add to-dos, and we're like, change this after 1 release, or relax this validation after 1 release, or tighten this validation after 1 release. Like formalizing that would be one really interesting property. Another really interesting property would be if you have a brand new cluster where you don't actually need to maintain compatibility with an API server 1 version back, you could actually enable things faster. It's like today the feature defaults are not version aware, and so we sort of have to play conservatively, and we would keep the default to be conservative. But if you could start a 129 cluster and say, actually, I don't have to maintain compatibility with the 128 cluster because this is new, feature gates can say, oh, well, we can enable a version earlier. So that would actually accelerate how we could deliver some things. And then long-term, this gives us a building block for possibly doing skip level upgrades, where instead of just saying maintain compatibility 1 version back, you could say maintain compatibility 2 versions back or 3 versions. Obviously, there's more things to consider there, but this is a building block.
Right. Then there was one more question that popped in my head, and it popped out right off. Yes, version skew. Like we just updated the version skew from 2 to 3. What language would we have to add or subtract from that skew proposal? I mean, skew policy, Jordan. Like if a 129 is masquerading as a 128, like and what is its relationship with the kubelets, for example?
Yeah, I think we would probably stay conservative to begin with and say, like, we understand 1 version compatibility, so the easiest thing to do would be to only let you choose the current version or the previous version as your compatibility version. To start. Right now, once a feature gate goes GA, we lock it on and you can't turn it off. And that lets us reason about, by this release, we can count on this feature being on and things like that. We'd want to be careful not to make things more flexible in a way that makes it hard to reason about. My guess is we would still lock feature gates on when they hit GA, unless you were in a compatibility mode type of situation, and where we say API servers have to be within this many versions. Like we would start to say that, and they have to be operating in the compatibility mode with their current version. So the idea is that you would use this during an upgrade, right? So you're transitioning from one version to another, and while you are in the middle of that upgrade, it could be useful to make components match the feature settings of the version you're upgrading from. But when your upgrade is complete, you should be with operating in a compatibility version that matches your binary versions. So I wouldn't expect people to be moving on further into the future, but still having binaries emulating previous versions of compatibility nodes. So we would want to, I don't know that it would change our SKU. I think it would change what we say about upgrades. Like when an upgrade is complete, all the binaries should be set to a compatibility version that matches their binary version. Something like that.
Yeah, it's going to be interesting. So another question then, what about feature gates that are there in other binaries like kubelet? I think here you're hinting that it is API server feature gates, but we have Kubania, we have.
Yeah, the compatibility version would apply to every single control plane component, including the kubelet. So when you upgrade, you would presumably start all of your components at compatibility version. Like if you're upgrading to 129, you would start it at 1.28, compatibility version 1.28.
So essentially, they are shooting themselves in the foot if they don't make sure that all the components have been updated with the correct flag for the correct version that they need to be backward compatible with.
It would be a little heavier and a little bit less. It would be a more coarse upgrade sequence. So I wouldn't necessarily call it shooting themselves in the foot. It's basically upgrades today, right? I mean, we're just
hard enough, yes. Yeah. Right. At least I'm okay with the fact that this is a cluster operator problem and not like an end user problem, right? Which makes it easier to deal with. We don't have to go tell everybody. It's just the operators that end up facing the situation.
David's been patiently waiting with his hand up.
I have been. I'm wondering where you are planning to discuss the details, because the broad strokes, yeah, it makes sense to be able to upgrade from n-1 to n, and then at a later date say, I promise not to downgrade again. Please now move me up so I use VN's features. That makes sense. Considering the reverse, particularly with APIs, is potentially difficult because of the runtime config flag that has to be enabled in parallel with certain features, and the fact that we continue to serve fields we would still know about for features that had been disabled but that did not exist on the prior levels. And so getting into all the weeds on what we do for that, where do you plan to go talk about that?
Probably the cap. I mean, I just wanted to make sure that people were not completely allergic to this concept to begin with, right? I mean, like, otherwise I'd be getting ahead of myself, I think.
I would say go explore for sure. The doc is a good start, and the cap is an API server, API missionary is,
yeah, but
it's an API machine
everyone, right?
That works.
Yeah. That's where you should start, right? Like, and then come up with something that will work for the rest of the binaries that is maintained by everybody else, right?
It's fine. The harshest edges I can think of are QAPI server and kubelet.
Yeah.
Right. Especially you're talking about upgrade, and this also goes into like things stored in the HCD and like how they get updated and whatnot, right? So it's definitely
there are definitely edges that are not tied to feature gates today. So runtime config you mentioned is one. Validation loosening, we don't actually tend to make configurable at all. We just hard code it and then relax it after a version. Cell functions and libraries and variables that we introduce over time, and then etcd storage versions. Like there's several things that are related to compatibility with the previous version, it would be nice if they could all be unified or tied to this system, so that when you say be compatible with one dot whatever, like all of those things just sort of fall into line. So yeah, I would thinking through each of those and figuring out how those map to this would be part of the design.
Yeah, I don't know if this is going to be in your scope or not, but like if you can drop, say somebody is on 125 and then they drop a binary for 127, and they don't have to like do the two-step tango of like dropping 126 binary and then run things, and then 127 binary and then run things, right? So if we can get to the newer versions, and it's like skip level upgrades, right? Of sorts. If we
that is definitely in view, and we want to get there. Yeah, that would be wonderful. We're keeping it in mind for sure.
Yeah. Don't rule that out. Is basically what I would say.
I think this like basically enables that, right? Like it is foundational piece for something like that to happen, right? Like if we don't do this, I think it's much more difficult to support skip level upgrades.
It's more difficult. It's certainly possible.
Yeah,
right. The information is already
way.
there. So.
Yeah.
Right. Okay, let's just look at the room and see if anybody else has a. Leila, did you have any questions? Because you said you were interested in this, or anybody else?
No questions from my side. I already reviewed the doc. Thank you.
Awesome. So, so general call to everybody else on the here today is go review this doc. It's linked off of the main SIG meeting notes. And get ready for a discussion in API Missionary. And please send a call out when you're doing this, so people from other SIGs can drop in there as well.
Yeah, it'd probably be good to send it to the mailing list as well for folks that miss the meeting.
Yeah.
It's been sent out to the mailing list. It's been sent out to Devin.
Sorry, I missed that. Okay.
I didn't know we were going to talk about this in this meeting today, but that's okay. Okay. So anybody else? Any other questions here? Going once, going twice. Okay. Rob, Scott, and Katarzyna, and Sergey, did you have any? Oh, Sergey is here, but Rob.
Yes, I'm here, Katarzyna. I'm here. Hello. Hi. So I would like to. I think so. We link the documents. So we'd like to propose a CAP to discuss the CAP. We would like to propose the new API run from kubelet, that the API will return the node local information about pod's readiness. And so our motivation is that there might be some workloads running on the node that would like to know the information about pod's readiness running on this node. And right now, there's the only way to know about the pod status is to read the kube API, and it raises scalability and reliability problems. And kubelet already owns some readiness statuses and runs them and reports them to kube API. And I think that it will be a bonus to add the API that can serve this data. And right now there is the gRPC API that's run pod resources endpoint, but there is no information about actually pod status. And our goal is to serve this, like I said, information which are owned by kubelet, and they are kind of independent from kube API. So, and yeah, so this is a proposal.
Sergey, did you want to start off this, any questions?
Oh, David has a hand. Maybe we can start with
David, go. please.
I was wondering if you could describe what's leading you towards a gRPC API over a REST API, just at a high level. Apologies if you did that at the top of the doc, but didn't notice it when I skimmed it.
Okay, so first, maybe the history. So there was this pod endpoint in HTTP, but it raised some concerns, mostly security concerns. And with the gRPC API, we'd like to achieve a watch model. So for example, we've got some workload that wants to know the pods running locally on the node information, and mostly so at the end, I proposed three actually services in gRPC. There's the get, list, and watch, because we think that the API to be more flexible, not only for more people's needs. But
yeah, Jordan, you can do next, or I can just answer for this. What do you want?
Go ahead. I had a separate question, so go ahead.
Okay, so yeah, let me just double down why we're bringing it here. So this in SIG node, we historically had a couple of REST endpoints that were never marked as officially supported. We never advertise them as something that you can use reliably, and we never advertise the schema of that. Recently, we introduced Pod Resources API. Pod Resources API is separate. It's a gRPC endpoint, and it returns mapping of pods to corresponding resources like devices. We started with devices, but then expanded it to CPU sets, huge pages, and other resources like that, like NUMA nodes. So this API is gRPC because we want it strongly typed. Now we have another scenario when we want to know pod readiness, and we want to know reasonably fast and reasonably reliable. So we thought that maybe we need to start expanding what we had as a success with Pod Resources API to expose new pieces of information. Some considerations why we want to bring it to SIG architecture is first, this is new guarantees, like surface of guaranteed APIs that we want to expose. And this API is like one complication with this API, it is not responding the source of like, it is a source of truth of what Kubelet thinks about state of world, but it's not a source of truth of what Kubernetes thinks about state of world. So if node lifecycle controller lost access to Kubelet, and Kubelet doesn't communicate with the API server, we will report the wrong status. We also have problems with Kubelet restarted and like catching up with the state, and it may not return what API server believes the state is, and it may return something else. So there are many complications like that. Yeah, in general, one question is API shape. We proposing gRPC as a new API, but we also trying to entertain idea whether we need to do a local API server kind of API. So do we want kubectl to be able to talk to kubelet and get same information? With Pod Resources API, we never thought about it because it's new information that the API server doesn't have. But with pod readiness, we kind of entering the territory of existing APIs that we already have surface for, and maybe we need to try to duplicate it to some extent at least. And with that context, I open for questions.
I guess I'm still wondering about my first question. So when I think about an RPC call, and where we've used it in the past,
comparing to REST it's easier to make it strongly typed and it's faster. We're also thinking about streaming support in future. So if we'll decide to go to streaming, having it started with gRPC will be easier.
So like, I think about an API I consider to be decently fast, an API that I consider to have decent typing, an API that already supports some level of streaming, already has a watch, and represents its objects. That sounds a lot like a QAPI server. Versus something where you have an RPC call where you say, please encode these bytes for me, please decode these bytes for me, which is clearly an RPC call, not something that's stored. So the primary and security, right? The security aspect, I think either way, you have to secure your endpoint. It looks like here it's going to be a Unix socket. That gives you some boundary on who can access it. But is it just you believe it to be faster and you think you need that additional speed? Is it the coupling? Is it just because that's what the previous one was and you just want to do that one again? I mean, it's
all of the above. So a little bit faster, easier to structure. Plus, it has we already have another API that is gRPC.
okay. I will say my first thought is if you actually made it look like a Cube API and then had it accessible via Cube control and then was able to use all of our existing encoding, decoding, schema conversion logic, it would give you automatic access to all sorts of Golang libraries that make it easy to write clients to interoperate with this. And choosing gRPC does not give you that. And now I'll turn it over to Jordan, who's waited very patiently for me.
Yeah, a lot of the things that Sergey mentioned, where like this is Kubelet's view of the world, not Kubernetes as a whole, or not Kube API server. I seem to recall that in the past there was confusion / accidental misuse of the pods endpoint that Kubelet was serving, where people were requesting that and thinking they were getting one version of the world and they were in fact getting another version. I think Kubelet, correct me if I'm wrong, I think Kubelet has 2 or 3 versions. Like one is its view of Kube API server state. One is its view of the container runtimes state, which could be slightly stale if it's polling. And then one is it's the state it has computed and is trying to report back to Kube API server, but may not have been able to or may not have reported back yet. So aren't there like 3 slightly different, slightly delayed states that are constantly getting reconciled in the kubelet?
Yeah,
it's not clear to me what this would be surfacing.
We also have container runtime view of the world, of something being terminated and need to terminate it.
Well, I guess, Jordan, did he answer your question? I didn't feel that, Sergey, you did.
I'm not sure. Which of those is this returning, and is that the right one? And are the clients we're expecting to use this proposed API always going to want the same view, or will some of them think they're getting one view but are actually getting a different one? The consistency issues on Kubelet startup especially worry me a little bit. Like if I haven't read the design yet, so if this is addressed there, I could read that. But on startup, like if the kubelet hasn't synced with the Kube API server yet, and we ask it for pods, is it going to return stuff, or is it going to say like unavailable? I can't give you that information right now.
Okay, so no, it's not like covered totally in detail in this design. This is like, let's say, the draft. But the overall idea is that when Kubelet is computing the pods data, the readiness probes or know about shifting the pods change the state, and those information are stored in Kubelet's cache. So our expectation within this API would be that the Kubelet will return the most recent data. And the reason is that sometimes there might be disconnection with Kube API, and we know that even if the Kube API is unreachable, the state or phase of pods might change. And we find the reason that it will be good to detect it with, let's say that the kubelet will report the actual state of the pod, not something that was reported to Kube API.
When you say the actual state of the pod, is that going to do things like include static pods and the most recently known container runtime status for all those pods? And what will it do in cases where it detects rogue things running by the container runtime?
Yeah, so I propose right now to expose the only the piece of the conditions that are owned by kubelet from status. They are containers ready, initialized. There are 4 of them, but honestly, I didn't cover the static pod secure right now. I'm sorry.
Okay, so the question from me is the assumption. One assumption here is something is running on the node that needs this information, so it's going to use the Unix socket gRPC to get it. What is that thing, right? What is that thing that is running on the node that needs this information?
I mean, so the controller that is, let's say, monitoring the pod's health, and the controller is interested in to know when or which pods are ready to receive traffic and which are not. And like I said, when Kube API is down, there may be the phase that Kube API reported that the pod is running, but actually Kube API is down, so something bad happened. Actually, the pod is not, let's say, not ready to receive the traffic or stopped to be ready. And there are some work that this worker would like to know this information to integrate better with. Yeah.
So one example you're saying is like a Cilium agent running on as a daemon set on the node would like to get latest information from kubelet without talking to the Kube API server.
Well, I'm not talking about specific Cilium. No, I don't think that Cilium agent would like to know for this particular. So I'm not saying the particular Cilium, but the agent running on the node which would like, for example.
Yeah.
So I guess what will they do with it is also the question there, right? Like once you know this information, what do you do with it, right? Like because there's nothing mutating about it. You are doing a list and a watch, but you can't really do anything else with the API.
Right. So we're coming from the networking perspective here. So we would usually be in SIG network, right? And this is very much a networking focused proposal. And what we're doing, and Cilium is one possible integration. It's not really what we're focused on right now, but the idea is that networking components running on a node should not be dependent on Kubernetes API server to understand the health of the pods running on the same node.
Yeah, that's why my head went straight to Cilium, because a networking problem, and you don't need to get off of the node to get the information that you need.
Exactly.
So, question in the scenario described, right? Kube API server goes down. While the kube is still running, it certainly has a cache. It knows what used to exist. Let's say Kube API server is down, kubelet crashes, comes back up. What would we expect to be served, and what would we expect a theoretical network plugin to do? I think right now the network plugin would also lack a connection and would probably default to do nothing, which would leave every container coasting. Kubelet starts back up, doesn't have the pods. What would we expect to happen?
So we expect that the endpoint will return the, let's say, complete information. So, and by complete information, I'm not saying that information that are reported to Kube API, but the kubelet, when it starts and stops serving. So I assume that kubelet right now needs to check the state of all of the pods, and until kubelet is, let's say, sure that the kubelet understands the actual pod state, then he can report the statuses. And I assume that when the kubelet is restarting, then all pods within the kubelet cache might be marked as unhealthy or unknown. So we don't want this status to be propagated, but we want to run the API at this phase that the kubelet is consistent and knows all the workloads steps.
I think I may
when the kubelet restarts, until it lists pods from the API server, it doesn't actually know what pods it should be running, and so it doesn't know which currently running containers it should kill or let coast. So I'm pretty sure it takes no action until it syncs the API server source. It might
It's a
take
little
action on
bit different.
static pod
It handles
containers.
static pods. So
Yeah,
it
so
knows
static
half
pods,
the pods that are supposed to be there, but it still cannot differentiate what the meaning of the things it's reading from the container runtime is.
right?
And
So I think there's
I'm
enough
not sure.
decoration on running containers for it to say, like, this was a static pod. I have synced my static pod manifest. I can manage those. These things I don't know yet because I can't reach the Kube API server. So the kubelet has enough information to sort of decide when to manage containers and when to not take action. But I don't think it has enough information to return a list of pods to a client in an API and have that be coherent to the client in that startup state where it hasn't synced its sources yet.
And to be fair, we already have this problem with pod resources API. So we already have customers complaining about it, and we're trying to address it to the best we can.
Well, yeah, but if the fundamental issue is it doesn't have the information, I just don't understand how this would help that problem.
Just trying to understand, does this mean that anytime kubelet loses connectivity to API server, it's going to crash?
No.
Okay,
the kubelet doesn't crash. The issue is that say I depend on this API, do I get a partial list back? Do I get no list back? Do I get a list back that is most likely complete but missing information? Do I actually want to run this as an API server with persistent data store so that I can start back up and know the last thing that I did? All those things are options, but understanding what this API is supposed to do is in these edges. Like I can appreciate you have this problem already in one spot. I wouldn't want to duplicate that problem in this spot. I would want to try to figure out how to address it before creating the API.
Yeah, the other question I had around is like we've delegated the CNI stuff to Containerd. Now we are talking about this as a networking focused KEP, and now we want to do more networking stuff in kubelet. Kubelet is already overloaded, right? So there is that question too, right? Can you do something in the Containerd layer itself, or the CRI implementation? Or I remember seeing something from Harry Wang in AWS around CNI stuff, making sure that the CNI related stuff get pruned appropriately when the pods goes missing and things like that. So maybe there's an opportunity there, but that is going to be Containerd specific. That's not going to be agnostic. So that is the problem there.
To be clear, like I like the idea of a kubelet API. I'm just not even sure what behavior I would want at these edges because it's not clear. Like I think I would sometimes want A and one not A. Like so, that's what I'm pressing on. Sorry, I'll let you go. Sorry.
Yeah, I want to reply to that. So when I said that we already have this problem, I'm not implying that we need to multiply this problem. I'm saying that we're already trying to solve this problem. So with this API, we will the exit criteria will be that we know what we're doing and we're clearly communicating what state we're returning. And going to Jim's question, like we don't have this information in runtime because it's readiness information, which is prop based. But I feel almost like we're trying to come up with APIs that is proxy between kubelet and the API server. So like let's return information, latest known information about what kubelet and API server talked about. That's why my thought went to this like kubectl on local cache of API server. I think that may be one of the options how to think about it logically and what we can try to implement. I don't know how much we can talk about shape specifically, and do we want to switch topic? But I really wanted to try to speak through, like talk to this local kubectl support. When I entertained this idea with Dawn, for instance, she was strictly against it. She like because it makes a lot of complexity in place we don't want to, and it opens the door for some misuses and like behavior. So I wonder if anybody on this forum has ideas about this specifically, some thought about specifically this idea, like do you want the kubectl on local API or not? Unless you want to continue on previous topic on edge cases.
I don't think we are that far, Sergey. But like, I want to tackle the basic issues first before we get to the point of like, is it kubectl or is it gRPC or not? That's, I think, further along the line.
I do think it's important for you to have a type system that you know will be able to evolve and
Right.
to be able to come in with an API that already has developed client libraries and client patterns is likely beneficial given the use cases that you're talking about, right? I'm thinking of my networking team, right? Like our Red Hat's networking team, they know how to speak kube stuff. There's a client library support for them to do that. The QAPI server, well, yes, complex, does provide a clear versioning story that we haven't had difficulty with. We are now, maybe Jordan probably knows more about the various gRPC endpoints that we have, but I think we're experimenting now with our third attempt at trying to version them in KMS v2. And I don't know how confident you are in how well that has gone.
Most of the gRPC endpoints we tend to have a single client. We use them for backend integrations from the API server or from the kubelet, right? This sounds like the target would be to have many clients, and so evolution there and compatibility there are a lot harder to reason about. Basically, your options are way more limited, right? If we make a change in something where we only expect the API server to be the client, we can go change the API server, or fix the API server, or evolve the API server. If you make a change on an API that has arbitrary numbers of unknown clients, that's a lot harder to evolve and reason about. I mean, gRPC in general has, you can evolve it, you can add fields. Versioning it is weird and tricky, and I don't really understand it. I think you just come up with a new name, and that's your next version.
And Jim, commenting on whether it's early or not, changing it to support kubectl, like complete API surface, significantly increases the cap size. That's why we really want to understand, is it a concern to go with gRPC, or we strongly need to investigate kubectl support? Sorry for interrupting.
I've got one other question that's just been burning in my mind, and it's related to authorization. So once an API like this exists, it seems likely that you will grow multiple consumers for multiple different purposes. And it is not obvious to me what authorization is anticipated as being required to differentiate a client that can access set of things A versus set of things B. And I didn't see it at a glance. Can you walk through what considerations have been there?
Yes, so it's not covered in the doc about this. Yeah, sorry, I don't have answer for that. I need
okay.
to...
I think that's also going to be useful to develop, because it helps you consider, like, by the time you build all the things that you need, do you end up more than half the way to an API server already?
Yeah, so our goal is not to replace the Kube API. We just wanted to, expose the things that are already, computed and stored by kubelet, and I'm not saying the share, but expose them locally. And our main concerns is this reliability and scalability issue. So I don't think that, I know that there might be a lot of workloads that's going to be interested in this API, but I assume that it will be one workload per, let's say, cluster node that it's gonna use this API, not that multiple workloads within the same node that's gonna use this API.
Yeah, maybe just to build on that a little bit, I don't know. We're trying to be very focused on a very specific use case, and I know it's very easy to think about how this could expand in the future. But if we say that the scope of this is forever going to be limited to information that is originating from kubelet, which I think is the goal here, that seems like it would limit the different kinds of authorization you would want here, but I may be missing some nuance.
Well, one of the first things as an extension you could imagine, like, well, CNI, well, now it works awesome while QAPI server is unavailable. I really wish my CSI driver would do the same thing, right? And it's local, and it wants to look at the pods that are available. Does it get to see the same ones? And that's just the next one that pops into my head, right?
Yeah, that's fair. I've been trying to take some notes here. I want to make sure I'm capturing all the different edge cases so we can have answers for them. I'm very aware about kubelet restarts. Are there other ones that I should be thinking about here? As I understand it, the main concern here is what we're doing in the time between a kubelet startup or restart and it having information from API server. Having complete information from API server. Is that the main edge case we should be worried about, or are there other ones?
I would probably start, so like the ultimate restart is the whole node restarts, right? So every container restarted, ones that were configured to come back up came back up, ones that didn't. The kubelet restarted, like everything restarted. The next layer is just the kubelet restarted, but containers kept running. And then there's sort of two flavors of it losing touch with the API server. One is it's lagging behind the API server. Its list watch went stale or got disrupted for some reason. And so new stuff has happened in the API server that the kubelet is unaware of. And then the other edge is the status it's trying to report back to the API server hasn't, that's not working for some reason. It's either stale or its writes are not working or something. Those are the ones I know of because it's how it interacts with the API server. Node folks, Sergey might have other edges where communication with container runtime
Jordan, also, like, kubelet gets upgraded to a new version. What is the experience to the thing that is
that's probably a case of restart.
It's a special case of restart because if the pod resource has a new field or whatever, right?
Although we do say, like, in place minor version upgrades without draining pods aren't supported, and you shouldn't do that. You should always drain your workloads first. So I don't know that that's an edge we care about here too much.
That's fair.
Okay, thank you for that. That's very helpful. I just writing that down, but thank you.
So I think another doc which covers the things that Jordan talked about would be good. It doesn't have to be a KEP at that point, right? Like, it can still be a doc like this, and we can do one more review of that before we can make some decisions there.
Yes, sure. Thank you so much. I just wanted one question. So I think that if we will do gRPC versioned API, then kubelet upgrades issue will be, let's say, solved because we will stick to the concrete version, right?
Mm-hmm. Yeah.
Yeah, and I just want one clarifying. So I understand that when kubelet restarts, then kubelet has some information about static pods, but needs to read all of the information about other pods from kube API. And when kube API is unreachable, so there is no information for them. Okay, thanks.
Right.
Yeah. Okay.
Okay, we have 1 minute left. Anything else from any? We made full use of the meeting today, so I'm very happy.
Yeah. Yeah, I didn't expect it will be so long, but thank you guys so much for the feedback.
Thanks a lot, everyone, and see you in 2 weeks. Bye, everyone.
Okay, bye bye.
Thanks.